Today I'm reviewing the ICPCON M-726, which is a DIN rail mounted device. Focus. It's also stackable, so it's DIN rail mounted, stackable. It's a multi-IO device. Quite a nice set of settings. Let's see if I can get my camera to zoom in. There we go. Quite a nice set of settings here. So you can have it in 4 to 20 milliamp mode, the inputs. So what it comes with is 6 analog inputs, 2 analog outputs, 3 digital inputs and 3 digital outputs. So what we're going to do today is we're just going to plug it in and we're going to play with some of them. I did get the 3 digital outs going, but I'll talk about wiring that up. I just don't have resistors and LEDs with me. So yeah, we'll have a look at that and see how we get on. But now we'll go over to the computer and have a look at the software. So what we're going to do is we're just going to look at it. I'll show you where you can download their drivers, which is from a very insecure FTP site, which causes its own issues. But this is a nice bit of kit. It's, like I say, very flexible, got a lot of functionalities. The one we're using, which is the Modbus RTU, is RS485. So it means you can string these things quite a distance. If you look at the RS485 spec. They're DIN rail mounted, which is very nice. 24 volt DC supply. I think it's variable. I think it goes like 12 volts to 30 odd volts, but don't quote me on that. I'll just kind of look. They're rugged. I've used these kind of things for on lots of different projects, and they don't go wrong. These are very good because of their range of analog outputs and inputs. Just having 0 to 20 milliamps and 4 to 20 milliamps is quite cool. I may do another video of how you set all that up, but for now let's just do some rudimentary comms. But you can see bit rate, baud rate is quite fast. It can go quite fast. So this particular unit is Modbus RTU, and Modbus is a very common industrial bus. It's worth knowing a bit about it. My wife's first company she worked at came from Modicon, and 1979. So it's used on a lot of PLCs and things like that, but it's royalty free and openly published, and which makes a lot of people use it. It also has an Ethernet version, which is very useful as well. So a lot of these things they're very handy. It's a good way of talking to stuff. When we get into the lab view, I'll show you how that's all sorted. So Modbus RTU is, oh god, it gets very confusing, but it's remote terminal unit. And it's used in SCADA systems, but it's used everywhere now. It's a nice comsy way of doing things, and you tend to be writing and reading from registers. So there's a standard way of talking to everything, and it's registers, or groups of registers. So it's once you've got your head around that, it's a fairly easy thing. Price wise, for something of this ability, it's quite a good price, I think. 256 quid. Like I say, 6 analog inputs, 2 analog outputs. I don't know what the resolution is, but it's got range setting here, so I'm assuming it's probably about 12 bits. But that's really useful, you know. So yeah, I like it. All in all, very good. So what they tell you to do, so you get a little leaflet in the box which tells you to go and download their stuff, which of course I've already done, but let's do it again. Sorry, I've got lots of things here, so let me have a quick look. at the documents. There we go. So you can see there it is. It's all in their documentation. They even give you a handy little QR code, as if my laptop blew down. And there's old-fashioned. You can see there it's whinging about not being secure. But anyway, I downloaded that and convinced all the various police programs that I knew what I was doing. It also comes with a manual, which is a generic-y big old manual for everything. I haven't had a look at everything else. And when you download it or open it up, hold on, let me come there. Let me see if I can get the file up so you can see what downloads. So once you've extracted it, it extracts to a file and you can run it directly from there, which again gives IT managers all sorts of headaches, I would have thought. So let's run it. I'm already doing that. Bonk. I happen to know this one's set up to for 9600 board, but if you don't know what it is, just click everything and it will go and search for what's on your COM ports. So I know it's COM port 12 and I know it's 9600, so but we'll do a search. Let me just make sure. Have you stopped? It's released it. And reception. Yeah, it doesn't surprise me because I've been using LabVIEW as well. It's probably going to give it a shared resource headaches. Let's see if I can release it. I might have to close LabVIEW. Yeah. Okay. Let's kill LabVIEw. Come on. Die and release it. Don't know what it's doing. Oh, right, there we go. Let's see if that frees it up. Let's have a look. Bonk. Bonk. Okay, that seems a bit better. And I'm only looking for Modbus RTU. And it's found it. So it tells you the type, it's a board address, which is useful again because it's RS485. You can string lots of these off of one line essentially, and daisy chain them out, and so then you end up with more addresses. So just carry on doing its thing. Okay, then when you double click on it, it brings up just a little user interface really. Doesn't appear to be running yet. I'm guessing it's waiting. Quite rudimentary sort of software. Might actually play around with that. So these are analog outputs, don't care about them. Analog inputs, and you can see here I've got 3.269 volts there. That's because I've got my little Pico here and I'm using its 3.3 just as a source. So if I hoik out that 3.3, I'm just going to hoik the pin out. You can see that go down to 0. Just proves that it's kind of measuring something. Plug it back in. It's back again. I think the other thing I did was, I think I pressed a button. I put the digital input button in. So let's have a look at digital inputs. Yep, there's my digital input. Bok. And then if I set analog output values, so it's set to 0 to 10 volts. So what's that one? Oh, that's better. Okay. It'll let me do it. I don't know. Let's go 2 volts. Boop. Go right. I've wired that cleverly into one of the analog inputs, and there he is. So there's our 2 volts. You can see, very nice. So this is their tool, which is very handy. Allows you to just set things up. Like I say, it's not the most brilliant thing in the world, but it's quite usable, quite helpful. So let's kill that, and we'll load up LabVIEW again. And then we'll just see. Sorry, it loads up on the other screen. That's why you get a blank screen. Boop. Okay, let's have a look. Recent files. There he is. Just got a test stub. Now we've rewritten this test stub to our own standard, but also I think their example software has got an issue with it. I think it uses the wrong register. I'd have to confirm, which I'll put in the show notes. But what I'll probably do is either link this or talk it up to a blog article and then link that from the show notes, just so that the software is available. But anyway, here we just select COM12. We know it's slave address 1, and then I think if we run it, let's just run it slowly to make sure we haven't got any issues. Okay, everything's tickety-boo. It's just sit there on the timeout. So on the timeout, what it does, just reads the inputs, so the analog inputs and the alert, and then whenever you do anything to the outputs, it will set them. And that's really literally all this is doing. Bonk. And you can see, here's our analog input. If I hoik 3.3 volts out, boop, it goes down to 0. Plug it back in. Actually, let's put a VBus on my Pico. Don't know what it is, 5 volts, I think. Yeah, it's 5 volts. It's quite high. Don't know what VSys is. Let's plug VSys in and see what he does. Oh, if I get my, can't see. 4.9 volts. Back to 3.3. I like 3.3. It's a good test voltage, I find. Yep, so that's on. If we press our button, there's our digital input being read. And then analog output. You can see he's got in his register what he was, so if we go like that, he goes down to 1 volt. And we go back down to 0 volts. Does it go minus? There you go, minus volts. That's quite nice. I think it's plus or minus 10 volts, I think, if I remember rightly. I don't know how sensitive that is. Sensitive enough, pick that up. So yeah, it's a, like I say, it's a cheap thing, but it's a good thing. Quite nice. These, as I say, they're very robust. You can stack them as well, which is very strange. They have little stackables, which will look a bit odd on the DIN rail, but kind of useful if you're constrained in space. Reasonably good temperature range. The digital out, let's just talk about wiring up the digital out. It is a open collector sync, which, just so that I didn't lead anyone astray, essentially what it means is that you wire your VCC, your high volts, so, and that can be up to 24 volts. The beauty of sort of open collector syncs is that you're connecting down to ground. Okay, so let me bring this across and then you can see it. So thank you, buildelectroniccircuits.com. Well, that's an open collector sync circuit. So you've got common on your inputs. So that will be hold on. Come on. Let's see if I can bring that up. Bonk. Data sheet. Do we have a? Hopefully we got some pins. Range. Okay, got wire connections here, which is kind of handy. Where's digital output? Yeah, so they're putting the load here and then down to ground. That's your open collector sync. So that's quite nice. In the data sheet, they show you how to wire stuff up. But for an LED, it will be that. that would be probably the same for a relay, most relays. So, you know, you'd have your relay positive, the coil positive there, coil negative there if it's a DC relay. And then that would work just nice. And then you just have a resistor to limit current. All very nice. So yeah, that's quite handy. It's got one common here, which is what the digital outs and digital inputs both use, that common. So yeah, there you go. Let's just review this. So let's have a quick look at Modbus. Below this is Modbus, and it's More Good Ideas Modbus from, it looks quite old, but it's fine. I mean, if we look at the VI hierarchy, it's nice and compact. There's not that many VIs, which is very good. This is what we like. So this is our bit, and then this is the drivers that came with it, and the examples that came with it. So again, if you look inside, bonk, there's our bit. You see, we just, and then you've got, you can set all your different bits and bobs there, so we just leave it on default. But sometimes it's quite handy with these devices if you've got a lot of them and you want your numbers, it's just you increase the baud rate. I mean, I had a system with quite a lot of these, and you had to just keep increasing the baud rate because you ran out of bandwidth essentially. You can see here's raw data coming in. Again, a Modbusy type thing. Boop. Actually, let's have a look. Let's have a quick look in and see. So we're reading our digital inputs here. Oh, didn't want to set that. Come on, get off. All right, open him up. So this is the More Good Ideas software VI, Modbus VI. It's nice. It's all right. Works fine. See here the decode is probably the interesting thing. It's just pulling it back into registers. Registers. So I reckon if we go even deeper, so read and write. Let's go for the read. Eventually we'll get to our serial port stuff. There we go. There's our read visa. It tells us the byte support, and it's doing a CRC, which is a checksum, and then somewhere in here we'll be converting it to numbers. Bonk. Exception Modbus data. This is vaguely interesting to me. Yeah, so here, this is where it's getting clever. It's doing number stuff. But once you've got over this kind of hump and you begin to understand what you're seeing, it's actually quite simple. You know, you're starting talking in bits and bytes. And you can actually, these packets are defined as the Modbus standard is defined, so you can actually work all it out. So it's pretty good. So that's quite useful. Yeah, so anyway, there's a whole range of these. It's not just these ones. Amplicon and measured in the UK, Amplicon sell them here, and Measurement Systems, who we got this one from. They do them as well. So again, similar sort of price. I think if you go like that, Modbus serial data acquisition, they got loads of different ones. It's quite a nice, flexible way to build a system. You know, it's like, oh, I've need a few more channels where it's only like 200 quid, and you just sling it on the end, and away you go. So it's actually quite a flexible way of building things. Obviously, it's not massively fast, but then quite a lot of systems don't need it. So, yeah, we've used these a lot, and they're good. There's ICPDAS. This form factor is very common. So the there's quite a lot of units that follow a similar form factor as well. So that's actually quite good too. So yeah, hurrah!